Dear students, welcome all of you. Today, I am going to discuss another very interesting topic cloud computing. Today's agenda includes definition and historical development of cloud computing, cloud computing, its core elements, architecture of cloud computing, benefit of cloud computing, some examples of cloud computing service providers, cloud computing application in libraries, library services, and cloud computing and its related technologies. I hope you will enjoy today's lecture. Let us begin. Let us begin with the introduction. The cloud computing is a transformative technology that provides users with access to computing resources such as servers, storage devices, databases, applications, and other services through the internet, commonly refers to the cloud. Instead of depending on local servers or personal devices, users can utilize remote servers hosted in data centers to complete tasks efficiently at a lower cost. So in this case, if you are using the cloud storage or cloud computing, in this case, there is no need to store the data in your local server or your personal devices. You can store it in a remote servers that is hosted in different data centers. This technology follows a pay-as-you-go model, allowing users to adjust resources based on their requirements, offering both flexibility and efficiency. By reducing infrastructure expenses, improving collaborations, enhancing mobility, and enabling easy access to data from any location, cloud computing has revolutionized various industries, including libraries. And some of the operations that can be performed with the cloud computing are storage, backup, recovery of data, delivery of software, development of new applications and services, streaming videos and audios. So, the last decades, we have reinforced the idea that information processing can be done more efficiently, that is, centrally, on large forms of computing and storage systems accessible via internet. When computing resources in a when computing resources in a distant data centers are used rather than local computing systems. We talk about network centric computing and network centric content. Advancements in networking and other areas are responsible for the acceptance of the two new computing models, and that led to the grid computing movement in the early 1990s. And since 2005, the utility computing, that is a centralized hardware and software resources, pay as you go model, being used, and the same year, the cloud computing also emerged as a path to utility computing and embraced by major companies like Amazon, Google, and Microsoft with this pay as you go model. Dear students, now let us discuss some historical background of cloud computing. In 1960s, John McCarthy, a computer scientist, suggests that computing may someday be organized as a public utility, similar to electricity or water. In 1960s, JCR Lickteur's vision of an intergalactic computer network at ARPA, now DARPA, aims for universal connectivity, laying groundwork for network computing. In 1970s, the advent of virtualization The IBM develops virtual machine technology, allowing multiple operating systems to run on a single physical machine, key for later cloud infrastructure. In 1983, the concept of grid computing emerges. You see multiple computer systems to share resources for large scale tasks. In 1989, as you know, the Tim Berners-Lee invents the World Wide Web, making the internet accessible to the public and setting the stage for networked services. In 1990s, the telecommunication companies start offering virtual private network VPN services, seen as the earliest version of shared internet-based infrastructure. Learners, in the 1997, the cloud computing term first appeared. In 1997, the cloud computing term first appears, defined by Professor Ramath Chelappa as a computing paradigm. In 1999, Salesforce launches as one of the first major software as a service SaaS platform, allowing businesses to access customer relationship management software via the internet. Major cloud players like Amazon, Google, Microsoft continuously expand services focusing on artificial intelligence and machine language, security, and hybrid cloud solutions. The birth of modern cloud computing we witnessed in the year 2002. The Amazon launches Amazon Web Services AWS, initially offering basic tools and services like storage and computations. In 2006, Amazon introduced Elastic Compute Cloud EC2, allowing users to rent virtual services. In 2006, Amazon introduced Elastic Compute Cloud EC2, allowing users to rent virtual servers, considered the official start of modern cloud computing. The major cloud providers emerged as in 2008, the Google releases Google App Engines. Another major development we witnessed in 2008, Google releases Google App Engine, enabling developers to build and host applications on Google's infrastructure. In 2010, Microsoft launches Azure, a full service cloud computing platform, expanding cloud competition. And in 2012, we have in the OpenStack, and 2014, Amazon introduced Lambda. So this services has expanded and given more maturity to the cloud services. And the adoption by enterprises and innovations in 2017, hybrid cloud models become popular, blending public and private cloud resources. In 2020, edge computing, bringing processing power closer to data source, gains traction alongside cloud computing for low latency applications. And if you discuss about the recent developments, in 2021, the global pandemic accelerates cloud adoption across sectors, making cloud services essential for remote work, education, and healthcare. At present, major cloud players like Amazon, Google, Microsoft continuously expand their services, focusing on artificial intelligence, machine learning, security, and hybrid cloud solutions. Cloud computing can be defined as, quote, a model for enabling ubiquitous, convenient, on demand network access to a shared pool of configurable computing resources. Example, a network, servers, storage applications, and services that can be rapidly provisioned provisioned and released with minimal management effort or service provider interaction, unquote. Let us discuss what are the cloud computing core components. There are 5 components that are delivery models, deployment models, defining attributes, resources, and organization of the infrastructure. In delivery models, we will find the 3 components there in delivery models. One is software as a service, that is SaaS. Software applications are delivered over the internet, managed by a third party provider. Users access the software via web browsers without managing the infrastructure, that is SaaS. In the platform as a service, PaaS, the provides a platform that allows developers to build, deploy, and manage applications. Users manage applications while the providers manage the infrastructure and operating system. That is a platform as service. Infrastructure as a service, yes, offers fundamental computing resources such as virtual machines, storage, and network over the internet. Users can manage the operating system, storage, and the applications while the provider manages the underlying hardware. Another component is deployment model. There we'll find the public cloud, private cloud, community cloud, and hybrid cloud. The next component, defining attributes, we'll find massive infrastructure, utility computing, paper usage, accessible via the internet, and the elasticity. And as far as the resources is concerned, this component contains compute and storage servers, network services, and various applications. And the organization infrastructure, it will contain distributed infrastructure, resource infrastructure, and autonomous systems. Dear learners, now let us discuss about the architecture of cloud computing. The cloud computing architecture refers to the components and subcomponents required for cloud computing. In this architecture, we will find the majorly 3 components. One is the front end, another is a back end, and third one is a cloud-based delivery and network. In the front end, you will have the client infrastructure, and the back end platform you have in the storage and the servers, services, and applications. And the cloud-based delivery and network you have in the internet and intranet or cloud interclouds. Now let us discuss what are the benefits of cloud computing. The cloud computing makes overall computing system very simpler. It improves data processing requirements. It helps in providing data security. It makes more modularized, result in better disaster recovery, gives good user accessibility, reduces IT operating cost, and another benefit is it provides high level reliability as well as the scalability. These are the major benefits of cloud computing. Let us see some examples of cloud computing service providers. We told you there are major providers are Amazon Web Service, AWS, the data of Netflix, Spotify, Uber, Pinterest. All this data have been lying in the Amazon Web Services. Microsoft Azure, that the data of Walmart, Starbucks, Coca-Cola, their data is preserved in the Microsoft Cloud Azure. And the Alibaba Cloud is having the ABS, CBN, Hang Seng Bank data is there. And Tencent Cloud, IBM Cloud, and Oracle Cloud, Kamatera Cloud. So all these clouds, you'll find there are major companies, major multinational companies, their data have been recorded or data have been stored in this cloud system of various agencies. So now let us see how the cloud computing can be applied in the libraries. OCLC has been functioning as a cloud computing vendor because they provide cataloging tools over the internet and allow member institutions to draw their centralized data store. OCLC has implemented the plan of library management system, that is World Share Management Service, WMS. So this is a fully integrated library service platform designed to meet the changing needs of modern literacy, modern. So it is a fully integrated library services platform designed to meet the changing needs of modern libraries. Another cloud computing application you will find in the form of a Ex Libris Cloud. Ex Libris is a leading library software vendor from USA. It provides cloud-based solutions to automate the library operations. And another application you'll find in the say DuraSpace Dura Cloud. DuraSpace provides open source repository solutions by undertaking turnkey projects of organizations and libraries to enable them to share scholarly literature using DSpace and Fedora Commons. It is particularly devoted to improve and sustain Fedora and DSpace. So you can use various library services using cloud computing. For example, ebooks lending services. The cloud platform is now becoming popular to lend the ebooks. We can use union or shared catalog like OPAC using cloud computing. Current awareness service to provide the current information to the users, which become easy and using with the cloud computing. Digital preservation or scanning services, that means digitization and scanning work can be done centralized, and so one can avoid duplications of such time consuming work. Libraries can preserve the collections in digital form in the form of archives. Article delivery services, cloud computing can be used for article delivery service to the users by the libraries. Publishers are already using this technology for providing access to libraries. Information discovery. Cloud provides a platform to store all information that can access anytime from anywhere. So the information discovery and searching become easy and is very useful for researchers. Now let us discuss some related technology. That means the technology which is related to cloud computing. One is fog computing. The term fog computing was coined by Cisco in January 2014. Fog computing is an architecture that extends cloud computing to the edge of the work, enabling data processing, storage, and services to occur closer to the data source and user. It complements cloud computing by reducing latency, improving efficiency, and supporting time sensitive applications. You will find the related technologies, let's say edge computing. The edge computing is a centralized computing paradigm where data processing, storage, and decision making occur directly at or near the data source. Example, IoT devices, sensors, or local servers. By minimizing the need to transfer data to a central cloud for processing, edge computing reduces latency, enhances real time responsiveness, and decreases bandwidth usage. It is particularly valuable for time sensitive applications such as autonomous vehicles, smart devices, and industrial automation. So, this chart will give you a clear picture about how cloud computing, fog computing, and edge computing having the differences in the technology. If you discuss here about the architecture, cloud computing is centralized, fog computing is decentralized, and edge computing is highly decentralized. As far as proximity to data source is concerned, cloud computing is far from data source, relies on data centers. Fog computing is closer to the data source than the cloud, and the edge computing at the data source or device itself. It's a edge computing itself is a data source and data device. As far as latency is concerned, it is high due to network distance, but in fog computing it is moderate, and in edge computing its latency is very low. As far as data processing is concerned, cloud computing uses batch processing, fog computing uses real-time or near real-time processing, and edge computing using as a real-time processing. Use cases use cloud computing use big data analytics, global scale applications, and the fog computing uses smart cities, connected vehicles, and industrial IoTs. And edge computing is wearable devices, autonomous systems, and remote sensors. The use is also different. And the examples of cloud computing, you can find the Google Cloud, AWS, and Microsoft Azure. And the fog computing examples are Cisco Fog Computing, Dell Fog Fabric. And the edge computing examples are IoT devices like smart thermostats, augmented and virtual reality systems. So now let us conclude. By leveraging the cloud technology, libraries can reduce the cost associated with maintaining physical infrastructure, increasing accessibility to resources, and enhance the scalability of the services. Cloud-based solutions enable libraries to host digital collections, provide access to ebooks, journals, and implement integrated library systems with ease. Additionally, the flexibility of cloud computing allows libraries to adapt the growing demand of online learning, remote access, and collaborative research tools. As libraries continue to embrace cloud computing, they can further strengthen their role as information hub, offering more efficient and user friendly services. However, challenges remain, such as data security, privacy concerns, and dependency on internet connectivity. But despite these challenges, the potential benefits of cloud computing, including the cost efficiency, enhanced collection, and improved user experiences, make it a powerful tool for the future of library services. Thank you so much, dear learners. I stop here. We will be meeting again in the next class with another topic. Take care.